Hello everyone, greetings. My name is Putu Arindra, and now we will discuss the metallurgical chapter 13, that is about non-ferrous metals, a variety of possibility. And my main reference is a book that names metallurgical for the non-metallurgical. Okay, we next to the chapter 13.1. Okay, chapter 13.1, like metals, Al, BEMG, and Ti, high strength lightweight alloys are of great importance in engineering application for use in land, sea, air, and space transportation. 1 kilogram of metal saved in the design and construction of such a system can result in important weight savings in power plants, transmission system, and internal fuel requirement. There is strong demand for high strength lightweight metal alloys. The metal commonly classed as light metals are those whose density is less than the density of steel and whose properties meet the requirement for specialized engineering application. The density and elastic modulus for important metals in this group are these. These four metals and their alloy comprise the bulk of the high strength to weight ratio metallic materials used in industrial system. Aluminum is the most versatile of this material, and titanium is the most corrosion resistant, while beryllium has the high modulus and magnesium has the low density. 13.2 Corrosion resistant alloy. Non-ferrous metal and alloy are widely used in corrosive environments. At one end of the spectrum, they are used for water piping and food preparation. At the other ends, they are vital to the operation of many chemical plants dealing with aggressive acids and alkaline. There are two main reasons why non-ferrous materials are preferred over steel and stainless steels for many of these applications. There are a wide variety of non-ferrous metals and alloys that are well suited to this type of application due to their desirable physical and mechanical properties. For example, a high strength to weight ratio or high thermal and electrical conductivity may provide a distinct advantage over a ferrous alloy. Second, many of non-ferrous metal and alloys possess much higher resistance to corrosion than available alloy steels and stainless steel grades. For common non-ferrous metals used for their well-documented corrosion-resistant properties are copper, nickel, titanium, and aluminum. 13.3 Superalloys. Superalloys are a group of nickel-based, cobalt-based, and iron-nickel-based alloy that exhibit outstanding strength and surface stability at temperature up to 85% of their melting points, expressed in degrees Kelvin, 0.85 T. The iron-nickel-based superalloy are an extension of stainless steel technology and generally are rolled, whereas cobalt-based and nickel-based superalloy may be rolled or cast depending on the application and composition involved. Casing crystal forms are often produced for aircraft application. Superalloy are generally used at temperature above 140 degrees Celsius. They are initially developed for use in aircraft piston engine turbo supercharged. Current applications include aircraft gas turbine. There is this combustion chamber, ball casing, shaft, exhaust system, case, blades, fans, burner can, afterburner, plus reverse. And second, steam turbine power plants. There is ball, blades, tank gas, radiators. And the third, reciprocating engines. There is turbochargers, exhaust valve, hot plugs, valve seat inners. And the next is metal processing. There is hot work tools and dies, and casting dies. And the next is medical application. That's for dentistry use prosthetic device. Next is space vehicle. That's aerodynamically heated skins, rocket engine parts. The next is heat treating equipment. That is tray, fixture, conveyor belts, basket, fans, furnace mufflers. The next is nuclear power system. That is control rod drive mechanism, valve steam, spring and ducting. And the next is chemical and petrochemical industry. That is ball, fans, valves, reaction vessels, piping and pumps. Next is pollution control equipment. That is scrubbers. Next is metal processing mills. This is oven, afterburners and exhaust fan. And the last one is called gasification and liquefaction system. That is heat exchangers, reheaters and pit piping. Superalloy are intended to prevent or minimize scrap deformation at high temperature. They all have a center cubic structure. Iron and cobalt both undergo allotropic transformation and become FCC at high temperature, or with alloying nickel. On the other hand, is FCC at all temperatures in superalloy based on iron and cobalt. The FCC forms of these elements generally are stabilized by alloying addition. Alloying elements includes chromium, molybdenum, vanadium, cobalt, and tungsten. 13.4 is refractory metals. This family has 5 members, that is niobium, tantalum, molybdenum, tungsten, and rhenium. With the exception of 2 platinum group metals, osmium and iridium, refractory metals, bring the highest melting temperature of all metals. Tungsten has the characteristic of having the highest melting temperature of all elements. All refractory metals are readily degraded by oxidizing environment at relatively low temperature, which has restricted their use in low temperature and non-oxidizing high temperature environment. However, the application of protective coating system, primarily for niobium, has opened up their use in application in high temperature oxidizing environment in space. Usage at one time was limited to lamp filaments, electron tube grind, heating element, and electrical contact. Today, refractory metals are also found in application in the aerospace, electronic, nuclear, and chemical processing industries. 13.5 is low melting point metals. Bismuth is brittle, easy to cast, and not readily formed by standard working methods. Its melting point of 183 degrees Celsius is lower than that in thin-lead solder. Bismuth is one of the few metals to increase in volume upon solidification. It is diamagnetic and has low capture cross-section for thermal neutrons. Low melting points alloys such as BCDSN PBEN alloy, which melts at 47 degrees Celsius, are called fusible alloys. One application is sprinkler system triggering device. A nuclear research application takes advantage of a combination of properties. High density gives bismuth excellent shielding properties for blocking the passage of gamma rays. With its low neutron cross-section allows allow the passage of neutrons. Small addition of bismuth to iron and steel environment, their mechanability and mechanical properties. 13.6 That is reactive metals. Reactive metals readily combine with oxygen at elevated temperature to form very stable oxides. Reactive metals are extremely noble because of their passive films. However, they may become embrittled by the interstitial absorption of oxygen, hydrogen, and nitrogen. Hydrofluoric or HF acid rapidly attacks reactive metals such as niobium, tantalum, zirconium, and titanium, either as pure of alloy metals as low as 1 or 2% reactive metals in stainless or nickel alloys reduce their corrosion resistance to HF. Beryllium, titanium, niobium, tantalum, hafnium, and zirconium are considered reactive metals. Of these metals, beryllium and titanium are low-density metals and are often used for alloys in like structural application. As previously noted, niobium and tantalum have high melting points and are also classified as refractory metals. 13.7 This is precious metals. 8 metals are in this family. 2 of them, gold and silver, require little or no introduction. Not so well known as the 6 platinum group metals, which commonly occurs together in nature, that's platinum, palladium, iridium, rhodium, ruthenium, and osmium. Gold is extremely soft, ductile, and easy to deform. Chemically pure gold is 99.9% pure, and high purity is commercially available. Resistant to oxidation. Its outstanding properties: its color, yellow, is maintained in air or when heated. Gold is usually allowed to increase its hardness because chemically pure gold is simply too soft for use in common applications such as jewelry. 13.8 That is rare earth metals. The 17 rare earth metals make up a closely related group of high reactive metals, which mean they readily combine with oxygen at elevated temperature to form very stable oxides. Reactive metals can become embrittled by interstitial absorption of oxygen, hydrogen, and nitrogen. Titanium, zirconium, and beryllium are other reactive metals. The term rare earth is deceptive easy type. Rare earths are not necessarily rare. The name derives from oxidized minerals in which they are discovered. The family tree has these members, that is scandium, lithium, lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and the last one is lutetium. This metal is an alloy of the cerium group, and its less expensive rare earth in alloy form. 13.9, that's metalloids or semi-metals. There are some elements that act as metals under some circumstances and act like non-metals under different circumstances. There are no called semi-metals, but have been called metalloids or like metals. These elements tend to be semiconductor. Silicon is the important example. The other example include boron, gallium, germanium, arsenic, antimony, tellurium, polonium, and austenite. Silicon used in industry can be classified into metallurgical and semiconductor grades. Metallurgical grade silicon is produced by the reduction of sands in an electric arc furnace. Its content approximately 98% silicon. Metallurgical grade silicon is used primarily in the aluminum, steel, and silicon industry. Metallurgical grade silicon is also used for the production of chlorosilane and fluorosilane. 13.10, there is special purpose metal and alloy. Uranium is a moderately strong and ductile metal that can be cast, formed, and welded by a variety of standard methods. It is used in non-nuclear applications, largely because of its high density. Uranium and its alloy generally are considered difficult to machine, requiring special tools and conditions. The pad uranium is melted, fabricated, and machined following conventional metallurgical practice. Due to its mild radioactive, chemical toxicity, and pyrophoric properties, special precautions are taken in processing. Its toxicity is similar to that of heavy metals. However, due to its pyrophoricity, powders or chips can self-ignite when exposed to oxygen. Inhalation of excessive amounts of dust and fumes can cause various health problems, including kidney damage. Uranium is generally selected over other very dense material because it is easier to cast and fabricate than tungsten and less costly than gold or platinum. Typical non-nuclear application of uranium and its alloy includes radiation shells, counterweights, and armor-piercing ammunition, and such as for cannons mounted in tanks. Okay, that's all for me. If you have a question about this chapter, you can write below in the comment section. Okay, that's all from my presentation. Thanks for watching, and don't forget to like my channel. Thank you.